Hi guys, welcome to this video. Today I'm talking about hinges. More specifically, I will show you 4.5 ways to design 3D printable hinges in Fusion 360. Whether you're designing a simple hinge for a DIY project or including it in a larger 3D printed component, one of the solutions should definitely suit your needs. The first two solutions will be print in place, so you will not be able to disassemble them, while the other 2.5 can be printed separately and assembled. Let's get started. I'm starting with a sketch on the front plane. The two flanges will be the same thickness, so I can use one large rectangle for both of them. I will also need an inner and outer circle for the actual hinge part. In addition, I sketched two lines at the bottom to account for the overhang capabilities of my printer. Here I choose an overhang angle of 55 degrees. I will use symmetry in the end, so for now I will be extruding only in one direction. I start with the inner part of the hinge. For that I select the hollow hinge profile and extrude it. Then I add the flange part by extruding part of the initial rectangle, going further than the first extrusion. I use the join option to merge those first two extrusions into one body. Now I will use a small trick. In the end, the two hinge bodies should effectively fill the entire volume I've sketched out. So for the second body, I first extrude all the relevant profiles and choose the new body option. Then I remove the first body by using combine with the cut option, which leaves exactly what I want for the second body. Here it is important to check the Keep Tools option. We can see that the bodies already form half of the hinge we are going for. These bodies would certainly stick firmly to each other if printed like this though. So I add clearances. I start with the inner part. Here I use an offset of -0.3 mm on every face that could come into contact with the other part. On the other part of the hinge there is only one face left to offset. I choose the same value. Now we want to mirror the hinge. We finish each body by choosing the join option when mirroring. Finally, we can put the bodies in different components. As always, I want to check the clearances in a section view. This first hinge design is finished now, and I can go about slicing and printing it. The shaft part will require bridging. Probably the hinge will stick a little bit and we will have to break it loose. If we want to avoid this, we can go with the second design. I go back to the first sketch and delete everything else. The sketch can stay the same, except for this time we will not need the inner circle from the beginning. I extrude the first part just as before, just without the hole. For the second design I want to interlock the two parts using cones instead of a shaft. For this I create a new sketch on the face that will be pointing towards the other hinge part. Here I sketch a relatively large circle. Then I extrude it using a taper angle. I again want to use an overhang angle of 55 degrees, so my taper angle will be 55 degrees minus 90 degrees equals minus 35 degrees. I set the suitable extrusion distance so that the cone does not get too pointy. I repeat the trick from before for the second body, by extruding much of the first sketch before cutting the first body from it. Again, I have to offset the relevant faces to allow for clearances. Here I may want to even go a little tighter with the clearances on the cone face. I choose 0.2 mm. As before, I finish the bodies by mirroring. After that we can put the bodies into individual components and check the section view. By the way, feel free to like and subscribe, and if you have any feedback, questions or suggestions for future videos, please let me know in the comments. This is now the finished second design, which is also print in place. This means that we cannot disassemble the hinge once it has been printed. By making a few changes though, we can make it that it can be disassembled and assembled. Thereby, the parts can also be printed separately. First, we simply want to reduce the interference of the cone, so we decrease the height of the cone. To increase the compliance of the cone part, I want to add two slots. For that, I go back in the timeline to just before the mirroring. I create a new sketch on the top plane and project the side face for reference. Then I sketch out two rectangles of about the same height as the cone. The distance between the slots and the depth of them depends on your requirements. The deeper the slots and the smaller the distance, the easier it will be to disassemble the hinge. I extrude the rectangles using the remove option and cut through all of the body. After reactivating the mirroring and returning to the end of the timeline, this third design is finished and we can check if the clearances are still okay. The fourth design will be quite quick to do. I go back to the initial first body and delete everything after that. I again extrude everything and remove the first body. Next, I simply cut a hole through both bodies. For this, I sketch a small circle on the front plane and extrude it while displaying both bodies, choosing the cut option. I again set the clearances and am ready for printing. This type of hinge gets assembled using a shaft or a piece of filament. For 1.75mm filament, you might want to use a 2.25mm hole. Also, using a 2mm drill to clear the hole can be helpful. I will not show the mirroring at this point. If you don't want the filament to show from the sides of the hinge, you can use another trick. For this very last option, which I have counted half an option, I delete the hole I've just cut. I create a sketch on the right plane instead. Here I sketch the center line of the hinge, but let it bend away on the outside. I use this sketch in a pipe feature to create a bent hole. A piece of filament can be inserted after printing. To ensure that this will work properly, I would recommend choosing an even larger diameter, like 2.5mm. After adding clearances, let's have another quick look at the section view. So what design will you choose for your next project? I hope you've enjoyed this video and found it helpful. If you have any questions or suggestions, let me know in the comments. Have a great time designing and prototyping.